Indicate which of the following functions are quadratic. For the quadratic functions, expand and state the coordinates of the vertex. So in order to determine which of these functions are quadratic, we will need to expand them fully, or in some cases partially might be sufficient. So the first one is y equals x minus 4 times x minus 12 times x plus 2. I'm going to expand the following two binomials first. Just using FOIL, that's going to be x squared plus 2x minus 12x minus 24. Then I'm going to be using the distributive property and multiplying each of the terms in the first binomial into this polynomial. So I'm going to get x cubed plus 2x squared minus 12x minus 24x. And at this point, we're not done with this expansion, but so we could continue here. But we can already see that we have a cubic term here. And we're looking for quadratic functions. So that means that we do not want to have any cubic terms. And the only way we could potentially get rid of this cubic term is if there will be another cubic term somewhere that would, in this case, subtract out. So it says x cubed. If there will be another term somewhere saying minus x cubed, then we still have the possibility of getting a quadratic function. So we did the following expansion like that. And it's this first multiplication that gave us the x cubed. Now, we still need to continue expanding this, so we need to still expand it by multiplying the negative 4 into this polynomial, except that there is no way we can actually get another cubed term, because it's just 4 times terms that have a lower order than 3. So this means that in this particular case, we can already say that this is not a quadratic. So it's not a quadratic function, so we don't have to continue here. In B, y equals 3 times x plus 8 minus 2 times x plus 2 times x minus 1 plus 3x. So if we expand this, we're going to get 3x plus 24 minus, I'm going to expand the multiplication of the binomials first. X squared minus x plus 2x minus 2 plus 3x. Now we're going to expand this monomial times this polynomial. So that's going to be negative 2x squared plus 2x minus 4x plus 4 and then plus 3x. So now we can start combining like terms. So we can see at this point there are no cubed terms. The highest order term is a square term, so this will be a quadratic function. So the first term would be negative 2x squared. And then we're going to combine the x terms. So we have 3x plus 2x is 5x minus 4x is x plus 3x is 4x. And then finally the numerical constants. There is 24 plus 4 is 28. So there is our quadratic function. Now we need to convert this quadratic function to vertex form by completing the square. So we're going to factor out the greatest common factor from the first two terms, which is -2. And that leaves us with x squared minus 2x plus 28. Then we're going to complete the square. -2 x squared minus 2x. We take the -2 divided by 2 and square it. So that's going to be plus 1 minus 1. Now we have our perfect square trinomial right there. So we can go ahead and factor it. And that's going to give us -1. So x minus 1. Minus 1 plus 28. So at this point, I'm going to bring the -2 back into the bracket. So it's going to be -2 times x minus 1 squared plus 2 plus 28. And then if we clean this up, we're going to get -2 times x minus 1 squared plus 30. We want to find the coordinates of the vertex. We have it now in vertex form. So the x coordinate is 1, the y coordinate is 30. In C, so now I'm actually going to continue on a separate page because C is a bit more, it's going to take more space here. So in C, so it's y equals 2 times x minus 6 times x minus 3 minus x plus 5. So let's start by expanding this, multiplying out the two binomials. We're going to get x squared minus 3x minus 6x plus 18 minus x plus 5. We can now multiply the 2 into the bracket. 2x squared minus 6x minus 12x plus 36. We can now combine like terms. We can already see this is going to be a quadratic function. There is no cube term. The highest order term is a squared term. So we have 2x squared. Then we have -6x minus 12x is -18x. Minus x is -19x. And then finally we just have a 36 plus 5, which is positive 41. So here is our quadratic function. We go ahead and we factor out the greatest common factor from the first two terms, which is 2, which leaves us with x squared minus 19 over 2x. We go ahead and we complete the square. So we have x squared minus 19 over 2x. Now we're dealing with a fraction here. We have -19 over 2. We want to divide it by 2 and square it. So 19 divided by 2, if we divide that by 2, we get 19 divided by 4. So it's going to be 19 over 4 is half of 19 over 2 squared. We add it and we subtract it. And then we just had plus 41. So we have our perfect square trinomial right there, like that. So we're going to go ahead and factor it. Okay, so it's going to be x minus 19 over 4 squared. Okay, now this number right here, this expression, this quotient 19 over 4, remember that if you multiply it by 2, you're supposed to get, or if you take 19 over 4 plus 19 over 4, you should be getting the middle number, which you do. If you multiply it by itself, so basically squaring it, you should get the last term in the perfect square trinomial, which we do. So this is the correct factored form. And then we're just left with minus 19 over 4 squared. At this point, we're going to multiply the 2 back into the bracket. So we're going to get 2 times x minus 19 over 4 squared. And at this point, we'll have to evaluate this 19 over 4 squared. So if we square 19, we're going to get 361. So it's going to be 361. If we square 4, we get 16. And then, of course, we're multiplying this whole term by 2. So it's going to be 2 times 361 divided by 16 plus 41. So let's just, at this point, wrap this up by combining these last 2 terms here. So we get 2 times x minus 19 over 4 squared. And if we combine these 2 terms, we're going to get negative 33 over 8, which means that at this point, we have it in vertex form, where the x-coordinate of the vertex, actually I'm not going to be able to fit it there, I think. The x-coordinate of the vertex is 19 over 4. The y-coordinate of the vertex is negative 33 over 8. And then finally, let's do d as well. So actually, I might be able to go back here now. We can fit d here. We have y equals x minus 3, 3x squared plus 6x minus 1. Now, when we expand this, I would start by taking, you can take this x here, and you multiply it by each of the terms in the trinomial. And we can see that x times 3x squared will give us a cubed term. So we don't want a cubed term, we're looking for a quadratic function. Will there be an opportunity to get any other cubed terms that could remove that cubed term? No, because once we multiply the x into the trinomial, then we take the negative 3 and multiply it into the trinomial. Negative 3 times 3x squared is not going to give us a cubed term. Negative 3 times 6x, also not a cubed term. And negative 3 times negative 1 is also not a cubed term. So this means that this is not a quadratic function. And if you're not entirely sure about the reasoning, just expand it, and you'll see that it's a cubic function.